that you mentioned there, the performance and the robustness of the LED and trying to keep the LED, the crop fresh, very well aligns with our plant-centric LEDs. So thank you. So now we have many questions from our audience. They have entered to the live chat. Just to remind you, if you have any questions, feel free to enter, and my colleague will hand me over any additional questions. Starting with the first question I have is, besides cannabis, what other higher value crops would justify high intensity light as sole source lighting?
That's a really great question. Right now, at this moment, we are limited to leafy greens and culinary herbs. These are the quick-turning plants, but they don't require high intensities. Cannabis does, and it's being grown very productively in greenhouses as well as outdoors and with supplemental lighting. But cannabis is of such high economic value that they can even afford to grow it completely indoors with high power LEDs. And so this is being done. You couldn't make money on any other current crop. However, coming down the road, just within a few years, are plant-made pharmaceuticals that are going to replace mammalian cell culture pharmaceuticals for the medicinal and pharmaceutical industry. And I would think that the economic value of making pharmaceuticals using plants, and these would be genetically engineered plants, of course, that would make this, but then they would use sole source lighting or supplemental lighting, and even if the costs are higher, the economic benefits would certainly do it. So that's something coming down the road, and I think people who are in the vertical farming industry know this, and they're staying alive right now. About 3/4 of them are not profitable, or they're just marginally hanging on by the skin of their teeth profitability. But they know that higher value crops like pharmaceuticals are coming.
So by pharmaceuticals, like, does that include vaccines, medicines, and all sorts
vaccines, antibiotics, and then specific medicines that the genes could be modified for, and then gene editing and synthetic biology even could be used to insert entirely new genes for this.
Wow.
Yeah.
That's very good to know. Never thought about the pharmaceutical applications.
Actually, it's a great future for CEA.
Wow.
Because of things like this.
That's amazing. The medical industry is huge, and having that to grow and control the plant and nutrients in it, I see definitely to be beneficial. So thank you. The second question I have is, how does light intensity differs in greenhouse versus indoor solar lighting? How is the light intensity differs in supplemental lighting compared to the indoor lighting?
Yeah. Well, as I said this morning, we also try to keep greenhouse supplemental lighting as low as possible. But the reason that's possible is because of higher levels of solar lighting. And so in the greenhouse, we are able to grow reproductive fruiting crops more easily than we can do it indoors. Oh, we can do it indoors with the high power LEDs and really put the energy to it. But for the price point and the economic value that you can get out of them, it would be really hard to make money. And so that's why the indoor ag vertical farming industry is growing the crops it is right now. And I'll tell you, microgreens and baby greens are really dominating even more than teen greens and leafy greens, because it's quick. It's 15 to 17 to 18 days, and then they clear it out and they can come in again. But in supplemental lighting, but in sole source lighting, you're paying for all of the light. Right. And that's what's limiting us right now to to crop selections. But the more efficient your LEDs are, like the PPEs and the decreasing capital costs of purchase and the long lifetime they have,
Right.
you extrapolate that out 4 or 5 years, they're going to it's going to work, and so the most efficient LEDs are going to win.
Nice, nice. Yeah, perfect. Yeah, that's what we see too, like the higher efficient LEDs, energy saving, all those factors playing in when we are trying to justify the LED versus the other traditional
Right.
technology. And that also aligns with the question I have next is there any industry standard for horticulture lighting, and what performance is reasonable, good enough? DLC and all others, like, they have published certain performances, but the market is way over than what is the industry standard performances, right? So is there any standard per se, or is it very crop dependent as what you select in terms of
Well,
spectrum and performance?
I don't think it's formal, but I think the consumer controls that when they go to the grocery store and they're buying leafy greens
Right.
in a clamshell or as a whole plant, and they're not going to pick up things that are wilted and brown. In other words, if they've been on a truck from California for 5-6 days, they're not going to look so good. They might even be yellowing. But then you can also tell what plants have been grown under really low sole source light and higher. Crispiness, texture, flavor, and then I don't think people are necessarily advertising it yet, but the bioactive compounds, the phytonutrient content is going to become prominent on shelves. So I think all these standards are still forming that you're talking about, but certainly good-looking produce that's edible, flavorful, has texture, and is crispy. Those are kind of gut check standards I would have.
Right, right. Who doesn't want a fresh, crispy lettuce, right? So they're absolutely right about it. And we talked about the plant spectrum LEDs, and one of the audience is asking, can plant spectrum LEDs help make colors more vivid in flowers or other applications? We have seen where it can suppress microbial growth, improve freshness in the plant, in the crop. Do you think it can also be applied to flowers for the colors to make it more vivid?
Oh, yeah. We sometimes forget that a large sector of the greenhouse industry is ornamental. A lot of them are having trouble making profit, however, in the United States. But yeah, they're switching to LEDs for specific things like propagation, especially, and early seed, early plug development, things like that. Not so much the finishing of the ornamentals. They go out into the greenhouse typically, but they are showing that you can go from sole source lighting to natural solar with or without supplemental and do that. But what I'm seeing is a lot of interest on the part of ornamental greenhouse growers. Many of them have started making the shift to edibles, from ornamentals to edibles. And we'll see what happens with the trends, whether those trends continue or whether there's a resurgence of interest in the ornamental industry.
Right, right. Yeah. Absolutely. Yeah. And the next question I have is, like, would emulating sunset and sunrise by dimming the LEDs, red to far red ratios mainly, result in healthy plants?
Since we're talking about indoor ag here, we're probably talking mainly about food crops and right now about leafy crops. We do know that shifting ratios can affect the leaf expansion and the creation of photosynthetic surface. So, and I think we're already finding by adding far red to the PAR, we're speeding plant growth because they're getting larger leaves faster, and larger leaves photosynthesize more, and so those same plants become healthy. So unlike supplemental lighting in the greenhouse, sole source lighting in the warehouse, you don't have to wait for sunset. Right. You can just do it all the time, and you're and by the way, let me emphasize again that sole source lighted plants respond very well to low intensity lighting that the growers can afford in terms of responding to different spectral stimuli, far red, blue, things we talked about in my presentation. And if you did the same thing in the greenhouse, most of the time you can't get those responses. At higher light levels, plants are less sensitive to spectral light, and they tend to interpret it mainly as PAR. So you get more photosynthesis. But it's indoors at these low limiting light levels that they respond very well. So you can design your plant, and as we go down the road and LED fixtures become more flexible in terms of both dimming and spectral shifts, whether regardless of how it's done. And I know it can already be done. Right. And some of it is the way Samsung is doing it now by mixing white with some monochromatic reds, blues, far reds. But when those can be channel controlled, and I know that's more expensive, but when it's not, you're going to have great flexibility. But until that time, some species are going to grow better, and some are going to grow less well under the same spectrum.
Yeah, absolutely, and that's the beauty of LEDs. It's totally spectrum tunability. You can tune the spectrum with one fixture, dim the LEDs, right, and mimic whichever scene, sunrise, sunset possible.
Yeah. I would say that Samsung's use of the term plant-centric is fine. It's good. But the next step is going to be species-centric, and it's going to be cultivar-centric within a species. That'll be the next fine-tuning that we'll get to do.
Absolutely. I'll convey the message to our R&D lab. We're always looking for fine-tuning the spectrum. We kind of have, like the ratio of red to white, but then like to fine tune it, you're absolutely right. It's very species dependent, right? Even one recipe cannot be applied to same kind of plants within the family. So yes, that message will be conveyed to our R&D team. That's a very good point about tuning the species. So one other question the audience has is like, some studies suggest that there is 1% increase in yield with 1% increase in light intensity. So meaning you increase the light intensity versus the, on the yield percentage of increase. So what's our thoughts on it? Like how much light is good enough, or where in terms of indoor, is it crop dependent, or is it a general rule?
Yeah, so that 1% increase in light intensity leads to a 1% increase in yield. This is something that started in the greenhouse industry, and it's applied especially to tomatoes and reproductive crops. It's been studied in Holland, and it's found to be it's a rule of thumb, but it's not quite perfect. And the range of species that have been investigated, it's anywhere from 0.5% increase in productivity up to 1%. And they've correlated that it works best at low light intensity, it works best at warm temperatures, and it works best when CO2 is high. Right. Okay? So we know when those things are met, you can get close to the 1-to-1 in the greenhouse. I would think that in the sole source lighting environment of indoor ag, if the grower is doing a good job controlling all 5 of the cardinal factors of plant growth, and nothing is more limiting than light intensity per se, they'll come very close to that theoretical maximum 1%, 1%. It'll be interesting to see. But that started in the greenhouse industry, and it's logical to extend it to where we are now.
Yep, absolutely. I've seen people like, they have to say that balance other cardinal factors. It's not just light intensity. So you are absolutely right about it.
If your light intensity is, quote, too high, that means you're approaching saturation of the photosynthetic light saturation curve, and you don't want to go there. You don't want to grow plants at light intensities that high because you're past the point of diminishing returns, and for every % increase in light intensity, it's going to be curving over until you won't get any increase in photosynthesis.
Sure.
So that's why it works well at low intensity.
No, thank you. Is the propagation light, does red LEDs have any effect on during the propagation of the plant, or is it only going to be the white LEDs?
Do you mean like when we're rooting cuttings?
Rooting cuttings and
or
early
are we
seeding
germinating
stage.
seeds?
Germinating seeds, more in particular.
So there are some lettuce cultivars, the Grand Rapids types, that actually have a red light requirement for germination.
Okay.
And that is a phytochrome photoreversible thing. If you give them a minute of red light and then an hour later you give them a few seconds of far red light, they won't germinate. But if you just give them a minute of red light and you don't follow it by far red, they'll germinate within 24 hours. And I guess in propagation, it depends what you're looking for. If it's growth, red may do it. In terms of rooting, I really don't know what the effect of blue combined with red might be, or whether broadband would do it. But I'm guessing if you can propagate them under any kind of light, you can propagate them under broadband as well as narrow spectrum. I would think.
Yeah, you're absolutely right. I guess it can just mimic, the sunlight or same thing, and then be able to propagate, right, in the narrow or the full spectrum LEDs.
Yeah.
That brings us to the last question. Do you have any additional questions here? Okay. So here's the question, one more the audience like to ask is regarding the 437 nanometer peak. So in terms of when we do the testing, we saw like the photonutrients and the flavanol contents increase using the plant-centric LEDs. And his question is like, is that can be applied to all of the lettuce, or is there any particular lettuce family that can be generalized to, or 437, right. Is the effect of it, or is going to be...
I don't know, but I'm guessing that the 437 coincides more with a peak of a secondary blue peak of blue absorbance, either chlorophyll A or B, than the 450 does. And so in terms of blue light effects, it's more effective. I've also seen in the spectrum there that the red peak is down a little bit, I think, isn't it?
Right.
Yeah, so it could be other things besides 437 per se. I honestly think that's a great research question, and it's probably a new enough observation that it deserves some work.
Thank you. So with that, we come to the end of a question and answer session. Thank you again, Dr. Carey, for coming all the way from Indiana. Samsung teams and everyone here appreciates you being here. So thank you again.
Enjoyed it.
Thank you.